Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss about a very important topic. This topic is that linear regression model using Google Earth Engine platform. So basically, first of all, I will try to discuss about that some basic concept about that linear regression. So basically, linear regression is a fundamental statistical technique used to model the relationship between a dependent variable and one or more independent variable. It assumes a linear relationship, which means that change in the dependent variable is directly proportional to the change in the independent variable. So here you can see this is the simple linear regression equation. So here we can see that y, it's mainly the independent variable, and then x is the independent variable and y is the dependent variable. Okay, so x is that independent variable and y is the dependent variable. And here you can see the beta 1 and beta 0. So beta 0 is that constant or intercept. Okay, so you can also learn more details about the linear regression, about the statistical part. Simply search here linear regression model, and then you can find out, suppose you can easily know all of the things about that linear regression, how it will work, all of this statistical background you can easily learn from here. So basically you can see linear regression, it used to the algorithm in the data science, and basically linear regression we can do for the regression as well as we can also do for the classification. Okay, for the linear regression we can also do for that. So in this time we try to make the linear regression in Google Earth Engine platform, this platform, and try to find out the trend analysis about this. Okay, so here you can see here I already write the code about the linear regression, and we want to find out what's the condition of the NDVI for this region of interest, look like that, and what is the trend about that condition, such as also you can see the another code. Suppose you can see for this coordinate or for this point, what is the condition of the NDVI for the different time period. Okay, so here you can see we can also draw the linear line. Okay, so this is the mainly linear trend line. Here you can see the trend line is that upper, so it means that in this region for the different time period and present, it will also be increasing the vegetation in here for this region. Suppose I want to check the result for the other, so I simply drag and paste the other region and simply run that. So now I can get about this, what is the condition about this coordinate or about this location for the vegetation. We can get this, we can also get this high trend value also in here, high trend line. It will be increasing. It means that for this location or for this place, day by day increasing the vegetation. Okay, so basically linear regression, in here we can use here this function. This function is that linear regression. So basically it create a reducer that compute a linear least square regression with numx, it's mainly independent variable, and num_y, it's mainly dependent variable. So mainly when you want to identify the NDVI in here, so in this time we are using here the NDVI is a dependent variable and time is a independent variable. Okay, consider that and then try to make the linear regression analysis in here. Okay, so in this time you can see is input value, is input tuple will have the values for the independent variable followed by the dependent variable. Okay, the first output is the coefficient array with the dimension num x and num y. These the two data set or two variable. So in this time, the num-x will be that ndvi and num-y will be that time. Okay, independent and it's the dependent. Okay, so now we try to check about that code. So mainly what we can do. So basically in this time, first of all, we create the image collection about that Landsat 8 image collection. So in this time, we are using at the Landsat this image collection for creating the code Landsat top of atmospheric reflectance image collection. And we are observe the image collection from year of 2013 to 2000 present 2022. Okay, so between this time period we are using all of those images and then try to find out and then calculated the ndvi and then try to find out what is the trend of the ndvi for this region. Okay, so this is our image collection we are using in here. This is our shapefile boundary of Dhaka city boundary. We observe about that, and then the field contain the Unix time in the millisecond. So I simply use that the system time start, and then we are getting the cloud free image. So that's why using here the cloud max function for the Landsat 8 imagery. We can get the cloud max function and then use this function to add the variable for ndvi and time. We need to make a function to add the variable for ndvi and time and a constant. Okay, so let's go about that. So first of all, I take a variable name is the add variables and then take the function. Okay, I put the element name is the image and the curly bracket I compute in the fractional years since the epoch. So just I simply use the EE date, image date get time field, and then date difference EE date. I put this epoch date as a year, and then I also add a ndvi band. So for that I simply the function is the add bands, and then call my function with element name and use the normalized difference. Put here the near infrared band and red band and rename as the ndvi. So I add here the time and ndvi variable using this function. And after that, we need to remove the cloud. So for that, I simply copy the variables. So I simply use the map function and call this function variable name for the variables. As well as I also use the map function and call the cloud max function variable name. Okay. So now it properly add with my collection. Okay. So now we can plot the time series of ndvi at a single location. In this time, I use here the location such as the whole country, a whole city boundary of Dhaka city. I use it. So for that, I simply you type this and I also get the chart look like that. You can see. So when I print that, then I can get the chart look like that. Okay. So this is the chart of the ndvi. And now this ndvi, we want to create the trend, linear trend. We need to calculate the linear trend. So basically linear trend has a two variable we want to need, independent and dependent. So in this time, independent variable is a constant. It is a time. So independent variable is the constant and it's a time, and dependent variable it's a ndvi. Okay, so it's a different variable, and then we create this independent dependent variable. Now I compute a linear trend. This will have the two band residuals and 2 into 1 band called the coefficient. Columns are dependent variable. So just I simply call my collection, then select the independent and add with the dependent. So simply I put this equation is that. Okay, so y is equal to mx plus c. So here you can see y is equal to mx plus c. So this is the L plus. Okay, so independent and dependent you can put here. And after that, we can simply use here the E reducer linear regression, this function. So mainly it computed the result as a reducer, and it's compute the result about the as a reducer as well. We can also calculate it. The output is the coefficient way with the dimension with the independent and dependent variable. Okay, and it also computed a linear least square regression with the independent and dependent variable. So you can simply use this linear regression, and then we also try to add here this image in here. Okay, so basically we can get the image look like that. So basically we can get the some pixel value such as the black color and also red color. So it means that in the between this time period there is the no vegetation. This type of region there is the no vegetation, but between this time period it also increasing or decreasing. If you want to check it from here, simply click on here. We can get this. You can see this is our line. Okay, and you can see this line also decreasing. Okay, so this line will be decreasing. You can see it is the not high, it's a low level. You can see it will be decreasing, so from this chart we can say that this for the area of Dhaka city region between the time period year of 2013, okay, 2013 to present 2000, I check the time period. Between this time period, the NDVI is the low day by day, from year of 2014 to the previous present time. This NDVI is the low day by day. Okay, so this chart we can say that about that for the region of interest of the Dhaka city, NDVI trend line is low. It means that this vegetation is the decreasing day by day. If you want to download this data as an Excel file, simply click on here, and you can also get the check about this data. You can see the NDVI data we can get in here as a time series chart, and using this data we want to make the analysis about that trend analysis. Okay, and also get this trend line chart, and from this trend line chart we can say that for the region of Dhaka city between the time period year of 2013 to present time, the NDVI is the decreasing day by day. Okay, we can calculate about that. Not only for that, if you want to click, you can see the another code. So mainly this code is ready for that for any single location. Suppose I want to check about the location, so simply drag and paste in here and then click to the run. So now I want to check between the time period year of 2013 to present time, what is the condition of the NDVI. So in this time we can say that this time period year of 2013 to present time, for this region the NDVI trend line is the high. Okay, so it means that for this region NDVI is the increasing day by day. Okay, so because this trend line is the high, so I simply drag and click the run. So now I can easily get the result about that. You can see for this location what is the condition, what is the trend line, and when I can get the linear line, there is a no high and there is a no low line. Okay, down line. So it means that there is a no change. Okay, so there is a no change. So then we can get that there is a no relationship between the NDVI and time, because there is the no change. So that's how you can get the R equal to 0. And when I can get the value R is equal to +1, it means that it has the positive relation. When I can get the R value is that negative, it means that it's showing the result as a low trend line. Okay, so means that there is a negative relation. Okay, so I hope you can easily understand about my thought, and if you have any question, any doubt, you can just contact with me. Okay, and if you want to join my online training program for the Google Earth Engine platform, you can easily contact with me and you can easily join for our new batch. Our new batch start, the new batch class will be start from the 9th June. You can join in here, as well as after 2 days we also start our this new batch training. You can easily register, you can easily contact with this WhatsApp number, as well as you can also contact with this email. Not only for this, but if you want to join the next month, then it also possible, because every month we also arrange the online training program for Google Earth Engine and remote sensing analysis. Okay, thank you for watching that.